Hello, dear students. Welcome back to my YouTube channel. Am I audible and visible to all of you? Please let me know if I'm audible and visible to all of you. Hello, beta. Let me check now. 1 second. Okay, so we're having good vibes. Hello, beta. Good evening, beta. Uh, Isaac G. Yeah, hi, beta. Hello. Am I audible and visible to you? Please let me know in the comment box if I'm audible and visible to you. Yes? Am I audible? Am I audible? It's great, but I'm not getting my voice, no? That is the point. So how I can just confirm that I'm audible, right? I need to just hear my voice firstly. 1 second. Yeah, now I got my voice back. Yes. But I guess you are new in the channel, right? You are new, right? Isagi, right? Am I just pronouncing your name correctly? Yeah, I'm just audible now. Okay, done. But sometimes, no, due to some network issue, you know, right? So sometimes my video is lagging, so you need to bear the kind of things, right? So as you know that, look now, you can just see the name of the lecture is 7 star. Basically, this is the 7 lecture only, right? But some portion, 20 minutes we had done previously, and then rest part we will be discussing in this lecture. Hello, beta. The network issue is the main one, right? Yeah, definitely. You can understand, no? You can understand. Okay. So you are preparing for NEET, JEE, or for your board examinations? For what kind of examination you're preparing for? So let's start now. Network is fluctuating greater rate, but let us hope for the best. Hmm. Okay. So yesterday we were discussing about this numerical. Jay, that is good. You will understand. So in yesterday's class or day before yesterday's class, we discussed about this numerical. Sondarya ja, yes, beta. Yes, from next month we will be starting 11th also. Don't be in hurry, no. From next month, more definitely I will be starting to 11th. Don't worry about the 11th one. Whatever doubts you are having, no, beta, you can ask me there. There is no issue. My comment box is on, no. You can just let me know your issue that you are having. Okay. So definitely from next month we will just complete 95% or 90% of my 12th syllabus. Then I will start 11th also. Okay. नो बेटा आपका एग्जाम कब है आप किस सौंदर्य फॉर व्हाट एग्जामिनेशन यू प्रिपेयरिंग फॉर किस एग्जामिनेशन के लिए आप प्रिपेयर कर रहे हो if you are preparing for NEET is in 2026. If you are preparing for JEE, that is also in December, right? If you are preparing for board examination, that is also in next year. So we are having a plenty of time. Within 3 months, I will complete your whole 11. Don't worry about it. Look now, let us discuss this numerical. Let us discuss this numerical firstly. That is, we are having 4-5 months for that examination. Don't worry about it. 2027, we are having 2 years. No issue there. So look now, what kind of numerical we are having on the screen? Pay attention to this one now. A square current carrying loop is suspended in a uniform magnetic field. You can see it is a uniform magnetic field. And we know that in a uniform magnetic field, my net force is zero. We know this sentence, right? In a uniform magnetic field, net is zero. Okay. In a plane of a loop, if the force on one arm of the loop is F, the net force on the remaining arm of the loop is. Simply indicates that if we are having a loop, you can see now this is my loop. Current I is flowing. Let's suppose current I is flowing through this loop. Done. Now we can name the side side A, side B, C, and D. No issue, beta. Sondareja, don't worry about it, na. You can trust, right? You can trust on my words. Definitely before ending of 2025, I will complete your whole 11. You can do one thing now. You can do one thing. Firstly, just watch my 3 lectures on 11th: basic maths, vectors, and UND. Complete these 3 lectures, then you can just come back and just let me know what kind of quantity and quality I am providing to you in the classes. So if we are having a loop like this, so what is net force? Sir, net force, as we know that in uniform magnetic field, net force is zero. How many sides we are having? 4. Can I write now? Force AB, force BC, force CD, force DA, net is zero. Okay. If the force on one arm of loop is F, one arm of the loop is F. So look, these are identical. These are identical, right? These are identical. So what I can write here, no? Can I write here? Look, if force on this side is, if look now, if this side, let's suppose this side force is F. Okay. Now here what we are having? We are having 3 remaining sides. 3 remaining sides plus F is 0. So can I write now 3 remaining sides? 3 remaining sides came out to be minus F only. Answer is B part. Simple and easy. Done. Now next numerical. I will try to complete the lecture within some time, so don't worry about it. Okay, now this one. Okay, for this one numerical, I need to just let you know one concept. Okay. But don't worry about watching all these things. No, I am not. Look, I'm not curious about, and I'm not very interested about that. I need the watchers, right? If you are only one student is getting benefit from my classes, na, more than enough. I am not getting money from these classes. They're free classes. I have a stable job, right? So I don't care about these things. Okay, it's my passion, no? Teaching is my passion. I don't want these things. Look, beta. If let's suppose we are having an inclined plane. Suppose, look, if this is my inclined plane, inclination is theta, and we are having a wire current I is flowing. Okay, and this wire is having mass m. Wire is having mass m. This wire is containing some mass m. Okay, I want this wire to be stationary. My aim is now, if you need to write the aim, my aim is wire. I need this wire to be stationary. How this wire would be stationary? Look, let us just watch. This is my inclined plane, okay, with some angle theta, and here is my wire, and wire is going inwards. Okay, wire is having mass m. So let us just use now weight. Is this mg? Is this mg? Yes, sir. I guess this one is theta. So this is mg cos theta, and this one will be mg sin theta. This one will be mg sin theta. You can use your right hand for the force things. No, it is in this current is going inwards, right? And let's suppose my magnetic field is in this way. This is my B. So if my B is upwards, right? Current is inwards, so force is in the right direction. So you can write, sir, my force will be here. This is my force. This is my force. And what is force? I guess force is BIL sin theta. So you can get the theta is 90 degree now. So what you can write, sir, F came out to be BIL only. So let us just divide this, the force into component formulas. One component will be along this one. Done. Theta, theta. So this will be BIL cos theta. If you need this wire to be stationary, so these forces should be equal. Can I write now? Mg sin theta should be equals to BIL cos theta. Yes, sir. So for stationary wire, this should be followed. Okay. So if you need to write the title of these numericals, you can write current carrying wire. You can write current carrying wire placed on inclined plane. On an inclined plane. So this numerical is basically combination of magnetic effect of current with your 11th standard. How to break down the forces into the component form. That is means vectors, right? So let us do a numerical based on the same concept. Let us just do a numerical based on same concept. So we are having this numerical from a great examination. Look, you can just firstly take your words. No, look, a metallic rod. Okay, sir. Mass per unit length, that means m by L. Mass per unit length is given as 0.5 kilogram per meter. Done. Is lying horizontally on a smooth inclined plane. That we are having what? A plane. Angle is 30 degree. That means angle of inclination is 30 degree. Okay, sir. The rod is not allowed to slide down by flowing a current. That means my wire should be what? Yes. So the wire should be stationary. Okay. When a magnetic field of induction 0.25 Tesla, so B is given as 0.25 Tesla, is acting on it in a vertical direction. The current flowing in the rod, I need to get my current. Look, beta. Is this my equation? Yes. So can I write this equation as, look, I will take this L here. So it will become now m by L G sin theta, or I can take cos theta here. It will become now cos theta now. Then we are having 1 by B equals to I. M by L is how much? 0.5. G is 10. Tan theta and tan 30 degrees. How much? What is the value of tan 30 degree? Now I can write here tan 30. It is tan 30 degree. divided by B came out to be I. Now how to write this thing now? Look. Okay. Look better now. I. 0.5 into 10 is 5. Sorry, it is 5. Then we are having a tan 30. You can know that the value of tan 30 is how much? Is it root 3 by 2? No, it is not root 3 by 2. Why, sir? Because look, tan 30 is equals to sin 30 by cos 30, right? So sin 30 is 1 by 2, cos 30 is under root 3 by 2. So value came out to be 1 by root 3. So I can write 1 by root 3 divided by B. What is the value of B? B is 0.25. 0.25, this is cancelled out. Here I can write 100. Then 25 1, 25 4. So we are having 520. It is 20 by root 3 ampere. Is there any option related to this option now? My answer, it is 20 by root 3. It is 1.6. That is means it could be around. Yeah, it would be somehow 11.32. It will be 11.32. Done. Easy now. These are some easy numericals. Very easy numericals. But look, if you want to tackle with these numericals, you need to be very good with the concept. Okay. So firstly, I teach you the concept. What is the concept behind it? If my wire is inclined, then you can do this numerical. If let's suppose you have done everything but not this topic, and the same topic numerical came in your examination, what you can do then? Nothing, no. So it is better to just study more concept things. Okay. Next numerical. This is my next numerical. You can see now. Okay. So you can see this numerical now, and the numerical is like a wire carrying current I. Okay. Along the positive x-axis has length L. Done. It is kept in a magnetic field B. So B is given as, this is my B. I can write. Sir, B is given in my vector form 2I cap, 3J cap, minus 4K cap Tesla. Done. I is along x-axis. That means it is I cap, J cap. I is along x-axis. So my I is along x-axis. I current now has a length L. Here the length of my wire is L. If it is L in x-axis, so I can write Li cap. And now I need to find out the magnitude of magnetic force acting on the wire is. Sir, I guess if my current is flowing, so my force is how much? I cannot Q V cross B. No, sir. This is valid for my point charges. If we are discussing a wire, I can write F is equals to, it is I L cross B. What is F? F is the, I need to find F now. So what is I? Sir, current I is I. What is L? L is Li cap. Cross, what is B? B is 2I cap plus 3J cap minus 4K cap. So here we need to do a vector calculation. So I can write, I will take L outside, I can write IL, nothing. It is I cross I. So it is 2 I cross I plus 3 is I cross J minus 4 is I cross K. Clear? IL 2. I cross I is 0 plus 3. I cross J is plus K minus 4. I cross K is minus J. Done? IL, it is 3K cap plus 4J cap. If you need to find the, it is magnitude, I can write 3 square plus 4 square root. It becomes 9 plus 16. It is 5. Done? You can take your time. If you want to take your time, take your time. If you're having any doubt, if you're having any confusion, or if you want to ask me anything, you're most welcome. You need to just comment. No? Okay. Let's start now. New topic. Let's start now. New topic. And my new topic is like magnetic movement. Magnetic movement of current carrying wire. Of current carrying wire. Magnetic movement of current carrying wire. So what is the meaning of it? Okay. So this topic is extremely easy for those students who attended my lecture of electrostatic. Do you know why? Because everything is related. Electrostatics formula are ditto same in our magnetism. Same formula, same, everything same. And later on, you will find the relation between electrostatic force and magnetic force. So best advice from my end towards you is don't skip any lecture. If you are studying a lecture, let's suppose you are coming from this lecture. So this lecture would be very useful to you only when you have watched or when you have studied back lectures. Okay, everything is connected. Electrostatic, capacitor, current, magnetism, everything is connected. Even 11th chapter's concept are being used here. So it is only and only useful to you if you have watched previous lectures or if you have done your previous lectures from any source, from any lectures, right? Now, let's start magnetic movement of current carrying wire. We know one thing. Let's suppose we are having a charge, minus Q charge, plus Q charge. Okay. And both charges are at some specific distance L. Or we can take 12 also, there is no issue. Which problem beta? Queen, which one? This one? This one? Simple now. Look, we are having a wire. Yes, sir. This wire is placed along x-axis and its length is L. If the length is L, now you need to show your length in vector forms. That means vector means direction. So look, for direction, length is given along x-axis. X-axis means I cap. Okay, so I wrote here, so it is Li cap. Current I is I. Now B, what is B? B is I guess given here, right? This is B, right? So then you need to only apply your cross product thing here. I cross I. I cross I is 0. Do you know why? Look, because I cross I means I into I sine theta. I is same direction, so theta is 0 degree. So I can write sine 0, it is 0, so I cross I is 0. So if you want to ijk, it is I, j, k. If you are doing I to j, you will get plus k. If you are doing from j to k, you will get plus I, right? If you are doing k to I, you will get plus j. But look, I into j, we will get plus k. I into k, it is I into k. You will get what? J, but minus j. Okay. Look, up to this particular thing, you need to apply physics. This is physics, right? After this thing, it is purely your mathematics. This is maths. That's why in my mentorship session or in any session, I'm just telling my students, beta, if you want to be a good in physics, do three main chapters from physics: basic mathematics, vectors, and unison dimensions. Because in any numerical, 80% role is from these three chapters. Kavya Joshi. Hello, beta. Okay. Now look, as we know that if two charges are separated by a, but I took your name now. So if two charges are placed with some distance L apart, so we define a thing that is dipole moment. We define a thing known as dipole moment P, and it is a vector quantity from minus Q to minus Q to plus Q, right? If we are having a magnet, this is my magnet. If this is my magnet, we know that we are having two poles of a magnet, south pole, north pole. Okay, look here, if it is point A, here if it is point B, what is the charge of A? It is minus Q. Charge of B is plus Q. In the same way in my magnets, so we have S, so the magnitude or the intensity of this S is minus M. Magnitude or intensity of north pole is plus M. The working of the small m and the working of the small q basically are same. Intensity of charge, intensity of magnet. Done. So these m known as pole strength. This is pole strength. If L is the length of your magnet, so we can define here magnetic moment. What is magnetic moment? Here, so what is P? P means either charge multiplied by the length between them. Here is charge, so here I can write pole strength. Here is length, here is also a length. Same, na? Replica of it. So what is this capital M? Magnetic. This is magnetic dipole moment. It is magnetic dipole moment. As we know that one more thing. What, sir? We know that current carrying wire. We know one thing. What, sir? That current carrying wire. Current carrying wire or coil, it also behaves like a magnet, right? It behaves like a magnet. If it behaves like a magnet, so it should also possess dipole moment. It should also possess faces north or south. So if let us suppose this is my coil, this is my coil. Current is going in this direction, I current. Okay, take your hand, right? So magnetic field is upwards. If a magnetic field is upwards, so you can write, sir, these are coming, my magnetic field lines are coming from this side. If it is coming from this side, so it should be entering from this side. And we know one property. What, sir? Magnetic field line is coming from north pole and goes towards south pole externally. So if this is coming out, so coming out simply indicates that it is a north. It is north, right? So this is north face. You can see now it is going inside. So going inside means it is south face. So it is south face. So this current carrying wire or current carrying loop is also what? Similar to my bar magnet properties. So for this one, for loops of my charge particles, dipole moment is Q into L. For bar magnet, it is M into L. But for my what? But for my this current carrying loop, it is M magnetic moment equals to number of loops, current flowing in loop, area of this loop. What is this area? It is area of my loop. That is I is current. What is N? N is number of loops. So we are having different formula. We are having different formula for what? To calculate magnetic moment. We are having different for current electricity. Sorry, we are different for charges. We are having different for bar magnet, and we are having different for current carrying coil. For charges, Q into L or Q into L. Okay. For bar magnet, it is what? It is M into L. For current carrying loop, it is N times I into A. Okay. Now, sir, we know one thing. Sir, what we know now? We know one thing, that it is a vector quantity and it possesses a direction. It is a vector quantity and it possesses a direction. For this kind of problem, we know the direction of my magnet. It is from minus to positive. But what about this one? So for this one, I need to study something different. No? So what I can write here? I will write here direction of M. It is magnetic moment, direction of magnetic moment. So here you can use a right hand rule. You can use right hand rule. How, sir? How to use it? You need to use in the direction of current, sorry, in the direction of current. Curl your fingers. Curl your fingers. The direction of thumb is magnetic moment. So what is the meaning of it? Suppose we are having a loop. This is my loop. This is my loop. Okay. In this loop, current is flowing in this way, I, in anti-clockwise manner. Take your right hand. Current is flowing in this way, anti-clockwise manner. Take your fingers and curl in the direction of current. I guess I can curl it like in this way. Now, where is my thumb? Sir, thumb is out of plane, out of plane. If my thumb is out of plane, so I can write here, magnetic moment, that is M, it is out of plane. This dot means out, cross means in, dot means out. Okay. Suppose if we are having one more loop, this is one more loop, and my current is flowing in clockwise manner. Now, take my hand, curl your fingers, my thumb is inverse, so the magnetic moment, it will be inverse now. Simple, no? If you are having a scare, something like this, and my current is flowing in this way. Done? Fine. Take your hand, thumb is inverse, so magnetic moment will be inverse. If you are having a loop, if this is my loop, current is flowing in this way, so my magnetic moment will be upwards. One more example. If you are having something like this, current I is flowing. It will be in this way. So my magnetic moment will be here. This would be a magnetic moment. Easy or tough? Easy or tough or super easy? Easy, tough or super easy? Okay. I need your response. No? If you're truly studying, no? So you will give me your responses. But if you're coming from time pass, no? Then no need. Okay, look now. Let us do some numericals. Look now. If we are having a square, done? Look, 3D now. 1 second. Look. Okay. I guess this is visible to you now. This copy is visible to you. Notebook. Yeah. So if look now, if now current is flowing, you can just look towards my fingers. Now my fingers is direction of current. Now look, my current is going in this way. Now in this way, coming in this way. Okay, look now. My current is flowing in this way. That means my current is flowing anti-clockwise. This is anti-clockwise, no? Okay. Look now. Take your right hand. Take your right hand. Okay, take your right hand. Now curl it in the direction of your current. It is like this now. Like this, it will go inside and it will come from this side. That means it will go from this side and it will come from this side. Coming from this side or from this side. Done? Right? There is no such things, right? If you are just wanting, we are just dealing with 2D only, right? You know why? Because it is NIA. What is A? A is the area vector. Area simply indicates it is as what? It is not a space. It is not a space. We are not dealing with 3D. We are dealing with 2D figure only. Okay? Vansha beta, we are not dealing with 3D here. It is 2D only. Why 2D? Because it is NIA. A. What is A? Is the area. So 3D figure is not having area, that is having volume. Okay. If this is my a cube, sorry, it's my square, na? And if current is going in this way, my current is going in this way. Done? So if side is A, and if current is I, right? Side is A. Okay. So find M, direction, and it is magnitude. For direction, simply use your right hand. It is inside. So you can write, sir, M is inside. What is its value? Sir, it is NI only. Number of terminals, it is 1. Current is I. Area is how much? Sir, A square. Na? So my came out to be IA square. IA square is my answer. Similarly, if you are having something like this, look now. Circle thing like this, right? Yes, if it is a vector, na, let us suppose, so I can write M equals to IA square, then I can write like this in vector form. Okay, or I can write M IA square minus K cap. If we are having a structure like this and current is I flowing in a clockwise direction, radius is R. Firstly, M will be inverse. I will not show directions now. So M is equals to NIA. N is 1, I is I, area is pi r square. My answer came out to be I pi r square. Okay. Now, if we are having a triangle, this is my triangle. Current I is flowing. And if it is equilateral triangle, equilateral means side is same. If this is side A, each side will be A now. And each angle is 90 degree. So now, what will be M? Direction would be inverse, that we know. Done. Now, what are M? M is NIA, NIA. What is N? N is 1, I is I. What is A? A is 1 by 2 base into height. Done. I into 1 by 2 base is A, height. Height we don't know. So height means this one, no? This one. Okay. So this will be A by 2. This one is A. This is theta. So what will be this side now? I can write sine theta. So it is sine 60 degree. This is P by H. Sine 60 is root 3 by 2. P we know and H, no, P we don't know, H is A. So I guess P came out to be under root 3A by 2. That means under root 3A by 2. My answer came out to be under root 3A square divided by 4I. This is my answer. Easy or tough? Easy, tough, or super easy? Huh? I know na, sometimes my video stuck na. Don't worry about it. Okay, one more thing. If you're having a structure like this, look now. Current I is flowing. This is my center with radius r1 with radius r2, r1 and r2. Find mnet. Mnet. How to find mnet now? Firstly, sir, look here. This is what? This is a line, a line, a line. So is there any area of this line? If you want to write this area, is there any area of this line? Area is 0. If area is 0, so what is m? M is NIA. If area is 0, m is 0. So for this line, m is 0. For this line, m is also 0. What is these two things? These are semicircular things. These are semicircular things. For this one, internal is 1. Let us suppose external is 2. For internal, so I guess m is outwards. I can write m1, m1 is outwards. And m2, m2 will be inwards. Okay, what is m1 now? m1, is it NIA? N is 1, I is I. What is A? A is pi r square by 2. It is pi r square by 2, no? I can write pi. It is r1 square by 2. Why is that 2? Because it is a semicircular thing. So my answer came out to be I pi r1 square by 2. And m1 is outwards. Okay. What is m2 now? It would be I pi r2 square by 2. Okay. And it is inverse. So look, both are different and both are in opposite direction. And you can see now m2 is more than m1. Then now look, denominator is same, I is same, pi is same, but r2 is more than r1, so that means m2 is more than m1. So I can write mnet now. So mnet came out to be I pi r2 square by 2 minus I pi r1 square by 2. I will take I pi by 2 common. It is r2 square minus r1 square. This is my answer. Because we are going from a very easy numerical to somehow a very tricky numericals. Okay, this should be also your strategy. Going from slowly from a very low conceptual things to the higher conceptual things. Done? Okay, now one more interesting numerical. Numerical like we are having a wire and this wire is length is 12A. We are having a wire and the length of wire is 12A and it is resistance. This wire resistance is given as R. First, okay, look beta. We can do one thing now, beta. Be in the class. I will finish the class in 10 to 15 minutes. Then we will discuss this numerical once again, right? Don't worry about it. First thing is, I need to create an equilateral triangle. I need to create an equilateral triangle of side A. Second thing, I need to make a square of side A. For both these things, find M. For both these things, find M. Done? For an equilateral triangle, I guess this side is A, this side is A, this side is A. So if you are making an equilateral triangle, your perimeter is 3A, no? Your side sum is 3A, but total is 12. That means you need to just wrap it 3 times. 1, that is 3A, 6A, 9A, 12A. That means 12A is total, 3A is getting consumed, so it is 4. So 4 rounds. You need 4 rounds of these. That means N is 4. So what is M? M is NIA. N is 4. Current is I. What is area? 1 by 2 base is base. It is under root 3 by 2 times A. Look, 2 to 4, 4 cancel out. It is under root 3 times A square times I. Done? One more. If you are having square. Square is A. That means 4A. Total is 12A. You are consuming 4A. I guess your N is 3. If N is 3, so you can write M equals to NIA. N is 3, current is I. What is area of square? It is A square. So my answer came out to be 3IA square. It is 3IA square. Sir, are you an IIT? No, but I am not from IIT. I am from NIT. Okay. One more thing. One more numerical. If you are having two coils, one coil in this way and one coil in this way, both are at 90-degree angle. Done. And current is flowing in this way. I current. Second one current is flowing in this way. Okay. One is in this way, one is in this way. So look now, for this one, my M1, let us say it is M1 will be upwards. And for this one, my M2 will be this one, right? So what is M? Sir, M is NIA. Look, N is 1, current is I, A. Area of both things same, so area is A. So I guess M1 is M, so M1 is M, M2 is M. If we are having two vectors are at 90-degree angle. If you need to find the resultant, what is value? Sir, A square plus B square plus 2i is AB cos 90-degree. Cos 90 0, so my answer is A square plus B square. Okay. So if A is M, so it is M square plus M square root. I guess answer is how much? M root 2. So the answer is M net is equals to root 2 times M. Easy or tough? Okay. If you need to just further classify it or simplify it, so I can write M net is equals to root 2 M. What is M? M is NIA, right? So it is root 2. N is 1. I is I. Area is pi r square. Pi r square. My answer came out to be under root 2 I pi r square. This is my answer. Okay. One more numerical. A numerical like if we are having a line, current flowing I, and line is L length, and we want to convert this length L into a circle of radius R. Right? Find magnetic moment in terms of this L. So I guess M is NIA. Okay. N is 1, I is I, area is pi r square. Done. So my answer came out to be pi r square. Done. But I need the answer in L. I guess the length of this wire and the circumference of this circle is same. So can I write L equals to 2 pi r? R came out to be L by 2 pi. I can write here it is pi L square divided by 4 pi square. This is my answer. Okay. Okay, now let us discuss one thing. And I guess you know it from your electrostatic chapter. That is simple. That is simply if we are having a loop. One second now. Similarly, if we are having a loop, this is my loop. This is my loop, right? This simple notebook represents loop. Okay. And let us suppose this loop. On this side, no force is applicable. On this side, no force is applicable. On this side, one force is applicable, that is the right side. On this four, leftwards force is applicable. But this force and this one force, both are exactly same, but opposite in direction. What will happen now? Look, FF, it will rotate. Okay, this will rotate. Look now, one force is in this way, one force in this way. It will rotate. So can I write now here? If let us suppose we are having a loop. If suppose we are having a loop, this is my loop now. Current I is flowing in this loop. Look now. Current I is flowing in this loop. Done. And if here North Pole, South Pole. So what will happen now? There will be a magnetic field. There will be a magnetic field. This line represents my magnetic field. Look now. Take your right hand for force calculation. Take your this right hand. My finger should towards the current. It is upwards, no? Look, my finger is towards B. What is palm? Palm is inwards. That means the force on this side is inverse. Force is inverse. Here, force is 0. You can use right hand. Nah, it is not applicable here. Why? Because force is 0. If you can right hand here, look, now force is outwards. Force is outwards. So on this side, on this particular side, my force is inwards. On this side, force is outwards. So if we are having two forces, equal and opposite forces, yeah, one thing we know that, what's that? That force net is 0. We know this thing. Net force is 0. Why? This is inwards, this one is outwards. Both are balancing each other and it is 0, no? But what is the effect of these two forces? Because of these two forces, there will be a torque, rotation of these things. And torque is not equal to 0. Okay, it will rotate. It will rotate. So what is torque formula from my electrostatic? Is this P cross E? So here, I guess if I need to write torque, P. What is P? Dipole moment. Here I will write magnetic moment. Cross cross. Here is electric field. Here it is magnetic field. So what is M? I can write it is MB sine theta. What is M? M is Ni. I can write NIAB sine theta. If you need to write the torque like this, it is what? M cross B. It is MB sine theta or NIAB sine theta. What is this theta? Theta is the angle. What happens to it? 1 second. Theta is angle between M and B. Theta is the angle between M and B. Done? Done, na? This is how your loop rotates. This is how your loop will rotate. Okay, one more thing. Last 5 minutes. Don't worry about it. Look now. Okay. If theta is 0 degree, what will happen? Sir, T is equals to MB sine theta. Tau came out to be MB sine 0 degree. Tau equals to 0. One thing. If theta is 180 degree, tau equals to MB sine 180 degree. And tau equals to sine 180 is 0, so it is 0 also. That means on 0 degree or at 180 degree, my torque is 0. My torque is 0. This one is stable equilibrium. This one is stable equilibrium. This one is unstable equilibrium. Okay, I am not defining these things very much because I discussed it and defined these things in electrostatic. Equilibrium means if my force is 0, if my torque is 0. These things we discussed in our last chapter. Done? Easy, na? Look better. Why I am teaching in this way? Because these simple formulas we derived and discussed in very depth in my electrostatic chapter. So it is time consuming and not a wise decision to repeat one single thing multiple times. So I know why this is stable equilibrium. There I just explained the whole thing. Why this is unstable, I explained this thing there. Na? So I am not going to repeat it again and again, right? Okay. So we are done with today's class. So let us take the previous doubt of my student. And doubt is from this class. Okay, this one. Look beta. Okay. If we are having a structure like this, look now. A structure like this. Current is flowing in this way. current is flowing in this way. Done. If radius of this one is R1 and the radius of this one is R2. Now if I take this one, this simple line, right? So this simple line, it is not having any effect on a magnetic moment, so I can write M is 0. Similarly, this straight line, M is 0. Why, sir, M is 0? Because area enclosed by these things is 0. So area is 0, area is 0. Done? Let us take these semicircular arc. If it was a circle, I will write pi r square. Now it is not, it is a semicircle. Semicircle. Semicircular means it is pi r square by 2. Right? What is M? M is NIA. We know this, no? So can I write it is NIA? Sorry, it is NIA pi. It is pi r square by 2. Yes. Look, if we are taking right hand for this particular thing, for this one, na, my M1 is outwards. For this one, my M2 is inwards. So what is Mi now? M1, it is N is 1, I is I, pi is pi, R is R1 square by 2. What is M2? M2, N is 1, I is I, pi is pi, R1 it is R2 square by 2. So my answer came out to be I pi R1 square by 2. Here it is I pi R2 square by 2. Look, both are opposite to each other. If both are opposite to each other, so I need to get it is net effect. So what is net? If both are, I will write big minus small. Big minus small. Sir, which one is big? You can see now, look better here. I is here, no effect. Pi, no effect. 2, no effect. You can see R2. This is R2 and this one is R1. I guess R2 is more than R1. Therefore, M2 is more than M1. So M net is M2 minus M1. When you are doing M2 minus M1, I will get I pi by 2 R2 square minus R1 square. Okay. Now, today is, I guess, what is date? So we are having 4. Done. 5 is tomorrow. Lecture number 8. 6 will be lecture number 9. 7. On 7th, lecture number 10, we will finish this chapter. Finish. Done. From 11th, from 8th August, we will start new chapter. New chapter. Done. So I wish you all the best for your future. If you are having any doubts or if you want to ask me anything, you are most welcome. You are most welcome. Okay. Thank you, beta. Bye. Good night.